In this video, we will see code implementation. Now let's quickly check the code implementation of this problem. Okay, so I have an array. Okay, what I will first do, I will simply sort it. So I will sort the array. So it will be a comma b and a minus b. Basically, this is the sorting. After this, what I will do, I will simply apply the binary search. So you can simply say that first I will apply the binary search. So I will take one s pointer that is at 0. I will take one n pointer that is ARR of n minus 1. Same. Basically, I am taking the last one. Okay. Also, you can take the range as I have decided, said it earlier. You can do AR of n minus 1 and AR of 0. Okay. That is also fine. Okay. But here I am taking the last element. Okay. After this, I will take res, basically res equals to 0. And then I will say while s, basically s is less than equals to e, I will apply the binary search. Right. And how I will apply the binary search? I will find the mid is equals to math.floor s plus e by 2, right? So s plus e by 2. Okay. And if I will check if whatever the element is, right, if I am able to place it, okay, basically from mid I will get the range, right, and if the range, by the range, if the number of routers are less, basically I will decide it whether I should move in the right direction or left direction. So basically let me tell you basically what I want to do. See, when I will store my answer, okay, I will suppose I will store the mid range and I will say n is equals to mid minus 1. If you can remember when I was saying mid minus 1, when by the given range, by the given mid, I was able to give the enough Wi-Fi supply. Okay. I was able to give the enough Wi-Fi supply, but I am finding out more lesser value. So what I will do, I will check if it is possible to give enough Wi-Fi supply. So I will call my place function, right? In place, I will pass the array and my mid range. And if it is true, so what I will do, I will say n is equal to mid minus 1. If it is false, that means by this mid range, not all the houses are getting the Wi-Fi. Okay, so what I will do, I will say then increase the Wi-Fi range. S is equal to mid plus 1. Okay, and after this, what I will do, I will simply return the answer that I am storing it here. Okay, whatever the answer so far I have stored here. Okay, now let's talk about what is this if place function. Basically, here I am placing my routers with this mid range and I am checking is it enough, like is it enough to get the range. So let's see, let me first give you the function place. In function place, what I am doing, function place, I have one array and my mid range, right? I am checking what is my starting range of the house, basically the Wi-Fi router. The starting range will be array 0. Basically from here your Wi-Fi router range will start. Then what will be your end range? So end range will be basically AR of 0 plus mid, basically the first position, then the mid range, then the again one mid range. So basically this will be your end point. You can say start point or end point. That is also possible. Okay. So then what I will do, I will simply say this is my routers 1, right? So number of routers, let's suppose I have started with 1 because basically one router I have located now, start range, end range. So one router I have already located. Now what I will do, I will start from for let I equals to 1, I less than my array length, array dot length, and I will do I plus plus. Now, if the array I, if the house is in the end range, if it is under the end range, I won't be require any router. But if it is greater than the end range, right? If it is greater than the end range, then a new router will be required, right? So a new router will be required. What will the new router start range? Again, ARR of I. What will the new router end range? That will be AR of I plus mid, right? And what I will do after this, again, I will do routers plus plus. Basically, that means I have increased the number of routers. Okay. After this for loop, if the number of routers are less than equals to k, that means possible that by the medium range, I can simply get all the houses, right? I can provide Wi-Fi to all the houses, so I will return true, else I will return false. Okay. And yes, suppose if this is the returning false here, so I will say increase the range. If it is returning true here, so I will say okay, that's a true, store that answer, but try for the more lesser possibility, because I need to find a minimum range, right? So I will do mid -1, and this will be your code implementation, right? So yeah, that's all about the code implementation of this problem. Why minimum Wi-Fi routers required. In the next video, I will give you a bit of dry run of this approach, basically how this code is working. Okay, so we will see the dry run in the next video. See you in the next video then.